Bismillah ar-Rahman ar-Rahim. I'm trying to improve this chapter because the previous audio was very lousy. So the first slide, as we can see, shows some drawings. On the left, we can see the hair hygrometer, which we will tell you about it later on. And then we have the dry and wet thermometer, and then we have the Regnall's hygrometer, and then we have another transducer thermometer. As you can see, the D and F, which depends upon the absorption of ultraviolet light of humidity, and at the same time, of course, will detect the changes. And on the left one, we can see the polymer. Polymer is a substance where it has large molecules, which is affected, as we can see, by humidity, which is recorded by electrodes. And then we have big diagrams on the right showing the ultrasonic industrial humidifier and the cascade humidifier and the HM humidifier on the lower left part. Of course, as we know that the nose are by passing the aeration or tracheostomy. Of course, it will affect the properties of nose filtering the air from bacteria and inducing humidification, which will definitely be affected by tracheostomy, as we said, and intubation. Of course, at the same time, the dry gases induces heat loss, because whenever dry gas enters the upper airway, it ought to be humidified. This humidification is being taken from the mucous membrane of the upper airway, of course, will affect the total heat of the person, especially in neonates, where they are capable of developing hypothermia. Units of humidity is expressed in two ways. First of all, the absolute humidity. It's the mass of water present in a given volume of air, expressed in milligrams in liters or gram per cubic meter. Measurements are numerical the same. They are the same. Whenever I divide each of them on other parts, we find it is the same. The maximum amount of water which is fully saturated at 20 is 17 grams per cubic meter, whereas at 37 it contains only 44 grams per square meter when fully saturated. So these two figures ought to be remembered: 20 and 17, 37 and 44. The relative humidity is a ratio of the mass of water present in a given volume to the mass required to saturate. Simply speaking, it is the mass present over the mass to saturate. Whenever I want to compare the 17 and the 44 milligram present in cubic meter, of course, it's not fair, because they are being compared in at different temperature, 20 and 37, though the difference is 39%. So whenever I want to compare or estimate the relative humidity, I must make the temperature constant. So this relationship between mass and mass, simply by applying the general gas law, knowing that the number of molecules equals PV over RT, and the mass is proportional to the number of the molecules. If V and if V, R, and T are constant, then relative humidity will be shifted to be a partial pressure to present over the partial pressure to saturate, instead of mass over mass. So we are going to express the units in partial pressure. Measurement of humidity. Most instruments measure humidity as relative humidity. So we are measuring a ratio of what is present over what to saturate. First of all, the hair hygrometer. As you can see, the hair hygrometer is made of hair, natural hair, or it could be, of course, artificial. Nowadays, it can be, it's attached to a pointer, and then we have a spring. So whenever humidity is being applied, this hair will lengthen and will activate the pointer over a scale. Of course, the range of this mounted hygrometer works at the range only of from 30 to 90% of relative humidity. So it measures the relative humidity. The second one is the wet and the dry bulb hygrometer. Simply, it's made of two thermometers, one on the left and one on the right. The one on the left, as we can see, is being exposed directly to the humidity, whereas the other one is dipped by a wick in water. So that definitely this area or this thermometer will be exposed more to a lower temperature because of the latent heat of vaporization. Of course, we ought to have a proper current in the vinicity of this area to assure the process of evaporation. The difference between the two thermometers will be taken from tables where we can measure the relative humidity. Nowadays, of course, in new instruments are capable to induce an radiation around this atmosphere automatically. The third hygrometer, which is the most important, is the Reynolds hygrometer. Reynolds hygrometer simply is made of a glass. This glass is coated with silver from outside, and then we have a thermometer in it, and we have a pump, and we have ether also in it. So whenever I induce pumping, of course, the process of vaporization will be induced, causing condensation of water from outside over the test tube, which will be notified simply by the silver coated tube. This condensation, or at the point where the condensation occurs, is called the dew point. So this dew point has been taken to estimate the relative and the absolute humidity. So simply speaking, as we can know, as we said before, that the relative humidity equals actual vapor pressure over saturated vapor pressure at the temperature, at that temperature. You see, this is most important. So now in this situation where we created the process of condensation, cooling the tube, we made a scenario. What's the meaning of that, Matt? That we induced some sort of cooling of this area. So we will create a temperature. This temperature is being taken from tables to estimate the saturated vapor pressure at the dew point. You see from the table. I will notice that whenever I made a pumping, this pumping decreased the temperature. Suppose it decreased it to a certain level. At the level where condensation occurred at the dew point, I take it from a special tables where I can estimate the saturated vapor at the dew point. So instead of dividing both of this on each other, we will divide the saturated vapor pressure at the dew point over the saturated vapor pressure at the ambient temperature, the temperature where the instrument was being used. Clinical aspects of humidity, we said before that, of course, whenever I inspire dry gases, this dry gases will induce mucus plugs, which will be difficult for the patient to cough, and it will be difficult for us to aspirate this secretions. And at the same time, the cilia by time, especially in long-term patients on ventilator, will be dried, and its capability to kick out the particles will be difficult. So this will induce some sort of accumulation of secretions. At the same time, of course, dry gases requires more moisture. This moisture is going to be taken from the mucous membrane of the upper airway, of course, taken from the total heat capacity of the human being, which is around 70 watt, which will be taken in the form of from 8 to 10 watt, which is a large amount from the total 70. So these are the most important points that must be considered whenever I talk about humidity regarding heat loss or the effect of dry gases on the upper airway. So normally we ought to have around 34 gram per cubic meter of water in the upper airway whenever the temperature is 34. Of course, the temperature, whenever the temperature is increased to 44, as we said before, this amount will increase. So we ought to have this amount naturally during anesthesia. So we have two differences to increase the humidity. First of all, humidifying the environment, or by humidifying the inspired gases alone. The first one is being used in oxygen tent, as we know, and incubators, infant incubators. And the second one is used in anesthetic practice, where we use humidifiers. Of course, humidification of inspired gases by instillating into the trachea may induce something called acid aspiration pneumonitis. So it is a simple method, but we must put in our mind this incident that may occur. Humidifiers, as we said before, we have first of all, the heat and moisture exchange humidifier, HME. It's made of two screwed plastic parts in which we screw them to each other. In it we have a fiber element, or a mesh, and a hygrogmatic substance as silica to absorb water. What happens with this method? Whenever this is being attached to the expiratory limb, of course, when the gases are coming out, it induces a condensation on it. So whenever there is condensation, there will be a release of heat. You see, so at the same time as we have condensation, the gas is being transferred to be liquid, and we have the latent heat of condensation. These two things will be added to the next inspiration, so that the patient will inspire gas where there is humidity and it is hot enough for him. Of course, this is being affected in tropical area. High temperature will affect the function of it. Of course, accumulation of secretions will increase the resistance, and we ought to change it every now and then to prevent cross infection and the resistance. And we must put in our mind in high minute volume ventilations. It could be affected in its function. Of course, nowadays we add a bacterial filter on it, so we call it HMEF humidifier. The water bath simply is a bath. This bath, we induce a process of vaporization. Of course, this vaporization will take latent heat, so we ought to have a heater. And whenever we have a heater, of course, we must have a thermostat to control the heat. This heat, otherwise, this heat will affect the patient scalding. So the range of this working apparatus is from the 40 to 45% up to 60%. You ought to not to make it more than that, otherwise it will affect the patient. Of course, sometimes this redundant tube going to the patient will accumulate fluid from the condensation. So we ought to have something to make it go back to the apparatus. Otherwise, it will be affecting the patient. The cascade humidifier simply is induced by making a foam of gases in chamber. This foam of gases increases surface area. Of course, we have also a heater, and as we have two thermostats, one in the apparatus and one on the course going to the patient to control the heat in case of the heat increased too much. On the other hand, we have what we call the heated element humidifier, which is a heated element. This heated element is dropped on its water. This water causes the process of vaporization going to patient. Of course, we have a collecting tube for extra water. And on the other alternative method, we have what we call a heating element. This heating element induces a heat of around 250. The other one was using only the temperature of 100. So this too much temperature in the presence of anesthetic vapor or drugs vaporized will be affected much. So it's not used during the process of anesthesia. Nebulizer is another form of humidifier, but it creates an aerosol pattern. It makes aerosol. So we have two types, the gas-driven nebulizer and the ultrasonic form of nebulizer. These are the two instruments used as nebulizer. First of all, the gas-driven simply is based on the Venturi effect or the Bernoulli effect. As we can see, we have a high flow of gas going, and then we have a narrowing at the end of it. And then we have it inclined tube coming from a fluid. Of course, as we know, at this area, whenever the velocity increase, the pressure will decrease. So this reduce pressure will entrained fluid from this liquid. Of course, this bubbles are high enough. Of course, I forgot to tell you that the water bath creates large bubbles. The bubbles ought to be baffled on their way to the patient. Means that it ought to be broken down into small particles. So whenever these particles come out, they hit what we call an anvil. Anvil is something used by the blacksmith whenever he used to use something to bang on this anvil. This anvil breaks down or baffles this droplets into a very small aerosol pattern to go to the patient. So this is the first one, the gas-driven nebulizer. The second one is the ultrasonic. Ultrasonic is made of, as we can see, a vibration surface. This vibration surface either is dipped in a fluid, or you can drop water on top of this. It rotates in a frequency of few megahertz. Of course, it's very speedy. This speed is capable to induce very fine particles of humidification to the patient. Of course, you must take care of too much humidification will induce, as we said before, what we call aspiration pneumonitis. And the drawbacks of it, of course, it is relatively expensive, but it's the most efficient vaporizer. The size of droplets of humidifiers, they range from 20 till less than 1 micrometer. Of course, 20 microns, it's large enough to be kept in large airways, and it's nuisance. That means that it's a trouble maker, you see. So this is not a good size. So we ought to have sizes ranging from 5 to at least 1 micron for the droplets to move easily between the upper airway. Almost if we have below 1 micrometer, it can go to alveoli and go and come easily. Of course, we must put in our mind that too much humidification can cause hypoxemia, increasing the resistance, of course, to respiration. All these are capable to induce hypoxemia, so we must take care. Of course, the relative efficiency of a humidifier is being exposed by this graph, where we have the types of humidifiers and we have the amount of humidity in gram per cubic meter. As you can see, that we ought to have at least 34 gram per cubic meter in the upper airway, and we will find that the first the cold water but type of humidifier cannot achieve this 34. Meanwhile, the other ones by as we can see can induce the amount required. Up to 100 can be induced by the ultrasonic nebulizer. So these are the correlation between the amount required to the types of humidifier being used. Thank a lot. Wassalamu alaikum wa rahmatullah wa barakatuh.